I'm trying to find a general formula for the perpendicular distance of any point to the plane. So if we assume that the plane has an equation of ax plus by plus cz equals d, then by choosing a random point on here, and then so let's find the random point on there. So I'm going to assume that this point has got a x of 0 and a y of 0. So I can choose that randomly, but then of course the z will have to be determined. So if I substitute these values into here, I will get ax, so x is 0, so 0 plus by, that's 0, plus cz equals d. So that tells me that p will have to have, if it's going to be on this plane, will have to have a z of d over c. Now, so the vector pq will be vector pq. So vector pq would be n minus begin. So it would be alpha minus 0. So that would be alpha. Beta minus 0. So that would be beta. And then gamma minus the z of p, which would be gamma minus d over c. From the equation of the plane, we could of course say what the vector n is, and that would be a, b, c. That's vector n. Now, what is the perpendicular distance? The perpendicular distance of q to the plane would be the same as if I projected onto the n and measured this distance. So really, that would be the perpendicular distance. So the perpendicular distance would be equal to the magnitude of PQ multiplied by the cosine of this angle. So let's call this angle theta. So the cosine of theta. Now, also going back to reminding ourselves of what the dot product between PQ and N would be, that would also be equal to the magnitude of PQ multiplied by the magnitude of N multiplied by the cosine of an angle in between. So as you can see, this bit here is in fact this and this. So if I take N to the other side, then that tells me that the perpendicular distance that I am looking for is in fact equal to the dot product of PQ and N divided by the magnitude of N. Well, the dot product is simple. To find the dot product of PQ, that would be the x of the PQ times by the x of N, the y times the y, and the z times the z. So in fact, that will give me, so we are getting very close to the final formula for finding distance. So it will be it'll be alpha times a, so that will be a alpha, and then beta times b, so that would be b beta, and then finally that times by that would give you c lambda, c times lambda, so that's c lambda minus c times that will just give you minus d, so it'll be plus c lambda minus d over, so that on the top is our dot product. Now on the bottom we got the magnitude of the normal vector. We are talking about the magnitude of this. So that would be the square root of a squared plus b squared plus c squared. So in fact, we just found a formula, general formula, for finding the perpendicular distance of any point with the given coordinates. So the coordinates alpha, beta, gamma. Alpha is here, beta here, gamma. With the equation to the perpendicular distance of that to a plane, which we are given the function of it. So A, B, and C and D will be known because we know the function of the plane. So we substitute the ABC in there and ABC in there, and that will give you a number, which would be the perpendicular distance of that point to the plane.